Hi everyone. In today's video, we're going to discuss about some tests that are based on students' t distribution. All of you may be familiar with students' t distribution in the sampling distributions. So here we consider two tests, that is the one sample t test and two sample t test. In the previous videos in this playlist, we have considered one sample Z test and two sample Z test. And now the students' t version of those tests are considered. So here also we are going to test mean. So before moving on to what is a students' t test, we shall see what are the basic assumptions that are required to perform this test. So the first one is the sample must be taken from a normal population or normal distribution. So the population must follow normal distribution. The sample observations must be independent. We usually take random sample, so we know the random samples are independent samples. Therefore, the sample observations are independent. The population standard deviation is unknown. When the population standard deviation is known, we were able to find the Z test. So, the population standard deviation must be unknown. Also, the sample size is small. That is, we consider the sample size to be less than 30. So, this is a small sample test. So, we shall consider what is a one sample t test. So, testing of mean mu of a normal population with unknown standard deviation sigma. So for that, let x1, x2, etc. xn be a random sample of size n taken from a normal population with mean mu and standard deviation sigma, which is unknown, where n is less than 30 is considered. We take x bar to be the sample mean and s square to be the sample variance, that is calculated from the sample taken. So what we have to do is we have to test two hypotheses. The symbol hypothesis or null hypothesis will be a simple one, which is h naught mu equal to mu naught, because we just have one population and we have to test whether the mean of that population is a particular value. So we take the mean of the population as the parameter mu, and we are going to check whether this mu is equal to a particular value mu naught or not. So we have three cases as always. That is, the alternative hypothesis could be mu greater than mu naught, mu less than mu naught, or mu not equal to mu naught. Now we shall see what is the test statistic. So the test statistic is Z is equal to x bar minus mu naught divided by S by root n minus 1 follows t n minus 1. That is, the test statistic t is equal to x bar minus mu naught. Here, x bar is a sample mean. Mu naught is that value whether we are going to check, that is h naught mu equal to mu naught. That is a given value. And S is the sample, S square is the sample variance. So S is the standard deviation calculated from the sample, and N is the sample size, and we have to find N minus 1. So this statistic follows a t distribution with N minus 1 degrees of freedom under H naught. So this is the test statistic. So as always, in case of the normal test or Z test, we were using the normal table to take a decision. Now we are going to take a decision based on the T table, students' T table. So the test procedure is similar to the other one. Here we have h naught mu equal to mu naught, and if h1 is mu greater than mu naught, then we will take a decision to reject h naught if t is greater than t n minus 1 alpha. So if we know alpha and we know the sample size, for obviously we know n sample size, so we can calculate n minus 1. So if n minus 1 and alpha are known, we can calculate that tabled value. We can calculate the t statistic, and we can find the tabled value for this n minus 1 and alpha. In all these cases, it's almost the same as what we are considering the other cases in the normal table. The only change is that here we are going to consider the t table. So it's the same in all these three cases. So we are going to find the value, the table, the value for t with n minus 1 degrees of freedom and at alpha percentage significance level. So now we are going to consider the two sample t-test. So the testing the equality of means of two normal populations having equal but unknown standard deviation. So we have two normal populations and we have to check whether the means of those two normal populations are same or not. But the thing is that here the sample size is small and the standard deviation is unknown but equal. So as always, we have two random samples of size n1 and n2, and those are taken from normal population with mean mu1 and mu2 and standard deviation sigma 1 and sigma 2, but it's unknown. And we consider x1 bar and x2 bar as a sample means and s1 and s2 as a sample standard deviation. Now we have to test the hypothesis h0 mu1 equal to mu2 against h1 mu1 greater than mu2 or mu1 less than mu2 or mu1 not equal to mu2 depending on the question we have. So the test statistic is t equal to x1 bar minus x2 bar divided by root of n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2 into 1 by n1 plus 1 by n2. Here n1 and n2 are the sample sizes, x1 bar and x2 bar are the sample means and s1 square and s2 square are the sample variances. So everything is known. If we have a sample, we can find all these from that samples and we can compute t or we can calculate t. And this is said to follow a t distribution with n1 plus n2 minus 2 degrees of freedom under h0. So the test procedure is h0 mu1 equal to mu2 for against h1 mu1 greater than mu2 is t greater than t n1 plus n2 minus 2 n1 plus n2 minus 2 comma alpha, and if then we'll reject h0, and if h0 is mu1 equal to mu2 and h1 is mu1 less than mu2, then we reject h0 if t is less than t n1 plus n2 minus 2 alpha, and in the last case when it is not equal to mu1 is not equal to mu2 if mod t greater than or equal to t n1 plus n2 minus 2 comma alpha by 2. So in the second case it is t less than minus t of that, and in the first case it is t greater than t, and in the last case it is mod t greater than or equal to t alpha by 2. So I hope this video was useful. Thank you.